Okay, here we go with notice number 9, using inductive reasoning for geometry classes. Make sure you put your name, date, and period. Our essential question is, how do you use inductive reasoning in mathematics? And you realize inductive reasoning is when you find a pattern in specific cases, and then you write a conjecture for the general case. A conjecture is an unproven statement that is based on observations. So it's like watching something and deciding a truth about it. So it's a lot of things you do in like science classes. And a lot of times with inductive reasoning, we can disprove them by coming up with a counterexample. And a counterexample is a specific case in which the conjecture is proven to be false. So it's like you can make a statement and say, this is true for everything. And if you find a counterexample, then it's no longer a true statement. So today's lessons, we're going to look for patterns that are happening to be able to predict the future, and that's using your inductive reasoning. So it's like on example 1 here, it says sketch the next figure in the pattern. Well, notice we have circles cut into 4 sections, and there's a dot in the top left corner, and then it rotates to the top right corner, and then it rotates to the bottom right corner. So logically speaking, the next one you have a circle cut into 4 sections. The dot will be more than likely in the bottom left hand corner. You can kind of predict the pattern. On example 2, they give us numbers. Describe the pattern in the numbers: 2, 8, 32, 128. And so then they want us to write the next 3 numbers in the pattern. Well, to go from 2 to 8, and then 8 to 32, and then 128, from 32 to 128. If I'm looking at it, it looks like 2 to 4 is a multiplying, 2 to 8 would multiply by 4. I don't know, 8 times 4 is 32. So I'm thinking, is 32 times 4 128? If I type it in my calculator, oh, whoops, I did the wrong thing. 32 times 4 comes out with 128. So this was successful. So to get to my next number, I'm going to take the 128 and multiply it times 4. And I see that it is 512. And then to get to the next number, I'm going to multiply that times 4. And I get 2,048. And then to get to the next number, I'm going to multiply it times 4 and get 8,192. So my conjecture is that I was just multiplying each number by 4. Okay, on number 3, it says make and test a conjecture about the product of any 2 odd integers. So product means I'm multiplying, and then odd integers, that's like 1, 3, 5, 7, 9, and on and on and on. So my conjecture, well, if I take any 2, like 3 times 5, that gives me 15. If I do 5 times 7, I get 35. If I do 3 times 9, I get 27. Okay, if I do, I don't know, 7 times 11, those are both odd numbers, I get 77. So what can we say about the product of any 2 numbers? Of any 2 odd numbers? Now, do realize I did just indicate the positives. If I was to do the negatives of these things, okay, I can do the negatives, and I can do combinations of those things. So my signs are flipping back and forth. I can do negative 3 times 5 and end up with negative 15. Or I can do negative 5 times negative 7 and still end up at 35. So I'm doing both things. So I need a conjecture. Okay, so I'm going to write my conjecture that says a product of any 2 odd integers is, and then here's my statement. Now, if I'm looking at my odd numbers, I see I have a 15, 35, 27, 77. If I put negatives, I have negative 15 and a 35. If I'm trying to pick strange numbers, say like 21 times 51. If I put an outrageous one, I look at it and I have 1071. So if I'm looking at all these numbers, what type of numbers are these? If I'm looking at them, and I can pick any ones I want. If I'm looking at these, they all appear to be odd. So the product of any two odd integers is odd. It's going to be my conjecture that I'm going to state. Now, this is all my test. This is the inductive reasoning that is taking place. This is your testing. Because realize, inductive reasoning is trying to find a pattern for specific cases. Here's all my general cases that I was using, so here is my conjecture that I'm stating. There's my answer. Alright, number 4. It wants to find a counter example to show that the conjecture is false. So here's my conjecture that they wrote. All odd numbers are prime. Well, let's see. Odd numbers were like 1, 3, 5, 7, 9, 11, 15, 17, 19, and on and on and on. The word prime means that it is a compound, or it's actually a multiple of 1. The factors, I'll say it right in a minute. The factors are 1 in itself. Okay, 1 in itself. So if I look at number 1, or looking at the 1, the only factors of 1 are 1 and 1. Of 3, they're 1 and 3. Of 5, it's 1 and 5. 7, likewise, 1 and 7. 9 is 1 and 9, and also 3 and 3. Right there is not a prime odd number. So this is false by 9's factors of 3's. Is not prime. Realize I could have done 15, 21, 25. There's several of them. All it takes is one example, and that's what they're saying. Find the counter example, just one, that shows that this is false. Okay, that is your examples for this this worksheet, this note session. What I want you to do is work your independent practice now, kind of following the same pattern we just made, and then answer your summary, and you'll have your notes done for notes number 9.